Assalamu alaikum. Hello everyone. Welcome to this new lectures. It's introduction to OOP. At the end of this lecture, should be able to define objects, oriented programming, OOP, identify objects and attributes and behaviors. Object-oriented programming. What's object-oriented programming? There are many definitions for object-oriented programming, and we can define object-oriented programming in these two definitions. Like the first one, OOP is an engineering approach for building software systems. If we want to build the software systems, so OOP is like a mechanism how to build a software system, or we can define OOP as a way to organize and conceptualize programs as a set of interacting objects that we can, in the phase that we are designing the program or analyzing the program and we want to design, so we can use OOP interacting objects. Objects, it's in our daily life we can see objects, and we are human are very good with dealing with these objects. So we human are very good in recognizing and working with objects such as a pen, a dog, or human being. Even all these could be objects. We learn to categorize them in such a way that makes sense to us. We may categorize them as animate object, for example, or inanimate objects, pets, friends, etc. If you look around, you see a lot of objects that can be defined as object. So we see chair, we see vase, we see sofa, everything here we can see as object. And we usually, as a human being, we usually categorize these objects with the properties or with the specification that makes sense to us. For example, if we can see these pictures, we can see bicycle, we can see a tennis ball, or we can see cars or a watch, car. And if we want to describe any of these objects, we can just say this is a small car with one door, or this is a tennis ball to play at tennis, or this is a bicycle, it looks a sport bicycle, and we can say that have many speeds, and I don't know, the color is black, it's a black bicycle. So everyone can describe the objects he sees in the way that makes sense to him. So sometimes, as I said before, sometimes we classify objects based on their attributes. For example, if the object, we talk about apple, so we can say green apple or red apple, if we talk about people, we can say, if you want to your friend, for example, and you can describe him as fat or slim, or it's curly hair, or red hair, for example, or brown eyes, has a brown eyes, or he has a black eyes. So you can categorize or describe the people based on their attributes or based on their specification that he has. In addition, attributes, all objects exhibit behaviors. So for example, going to talk about dog, the attribute could be breed, color, hungry, tired, and the behavior, every dog he eating, sleeping, etc. So these are the behaviors that every dog do, and the attribute that differentiate between dog and another dog, these like the color, hungry and tired, and these are the specification of the dog type. And in the computers also we have objects, and we can say, if we want to build a pancake system, for example, and these pancake systems, during analysis, we want to know what's the objects that could be in the banking system. So we can deal with the banking account as a object, because the banking account also, it's not tangible. We cannot touch the banking account, but it's behaved like the other object that we see in our daily life. So, for example, the bank account has attributes and has behaviors. So, every bank account has account number, and every bank account has account name that represent to the owner of this bank account, and every bank account has a balance that money exists in your account. And the behaviors in every bank account, we can withdraw money, so we can withdraw money through ATM machine or directly from the banking cashier, and we can deposit money. We can put money inside the bank account. So usually this is the minimal behaviors that you can perform on the bank account. So let's say, for example, the attributes and how every bank account has account number, and this is unique through the bank, and have a owner and balance. So these are some of the attributes that differentiate between one bank account through another. So if we have two bank accounts, we cannot have two bank accounts with the same number. And also, if you want to know bank account for whom this one, so we can know about the owner and the information about the owner. The operation, usually every bank account we can do this operation at least on the bank account. So we can, every bank account we can withdraw money, and when we withdraw money, so the balance will decrease, and every time we deposit money, the balance will increase. So okay, let's go back to the another object, and this is a toothbrusher. So these toothbrushers, take a minute and try to describe these two brushes. Okay, try if you want to describe or know what's the attribute for these toothbrushes. So from the look, I can say it's a red toothbrusher. So I described these toothbrusher during using the color. So one of the attribute will be color. So this is a red toothbrusher, and also I can describe the toothbrusher through its type. For example, this is looks like a soft toothbrush. There is a hard, also there is a medium. So for me, it looks soft toothbrusher, and I don't know, maybe you find another attributes it's related to you. The behaviors, every toothbrusher is choosing to brush my teeth. So this is I can say brush my teeth. This is one of the behaviors. Maybe you find another behaviors, or you behaviors that you can use these toothbrusher for. Every object contain of two main things. The first one is the attribute that we talks about, and the second one is the behavior. So some books, when they describe OOB, they say OOB, they talk about its contain attribute and behaviors, and other books they say no, it's contain a property and method. All of this is correct. So or talked about the property and method, or data and functions, all this is the same meaning. Every object consists of the two things. It's a property and method, or attributes and behavior, or data and functions. So we can say that the objects that we are talking about is a package, and that contain a data or function methods that can be performed on the data. The method can be performed on the data. The objects interact between each other through their interfaces. So in this way, we can define the objects and define the properties that make sense to us. And these properties usually it's affected by the method or the behavior that the object perform. And hide or focus or protect these properties and these methods through the interface of these objects. YOB, as we said before in the functions, it's modular. We can divide our program or our application into certain modules, so in that way we can lead us to easy code reuse. So whenever we want to build another systems, we can use the part that consists of the object, so we don't have to write again these objects. For example, if you want to build a student information system, SIS, so the object could be a student, because every student has attributes and has a behavior. So every student, we can say the attribute, for example, student number, student name, in which semester he is, and in which faculty, and in which department or program, and GPA. This is a very important property, because every student has a GPA, and this all information is different from one student to another student. But the behaviors that we can perform on every student is, for example, enroll in a course, or withdraw course, or these kind of operations that we can make or perform on every student. And usually, so when the students finish this semester, he will move to the next semester, and the procedures will follow to perform that task. So if you want to build a formation student formation system, and we assume that we have a student as a object, and we already built this student object. So if we want to extend this in student information systems, and we want to make attendance system, for example, so in attendance systems we need to use another student object, because the student, he will attend the class or not attend the class. So in that way, we can just take the module that we built in the student information system, the student module, and we reuse it in the new system, which is attendance systems, and we don't have to build the systems from scratch. Layers meaningless to understand at once, and we talk about this one in the functional. So usually big applications, and it's developed by a team, not by a person. So, and these teams work in the company, and there is a task assigned to each team member, and he has to write the code. Right, team member will be assigned to a certain part of objects, so he don't have to know the other objects, and so on. More self-documenting, of course, because every object will contain all the behaviors and properties that are related to that object in one package, so it's more self-documented than procedural code. Okay, let's take a minute and know what's the property. If we assume that we have an object called laptop, for example, and we want to know what's the property and behavior for the laptop as object. Okay, so if we assume that we have a laptop as an object, we can say the attribute that differentiate between one laptop to from another laptop is, for example, CPU, the processor that we use, Core i5, Core i3, Core i7, the RAM, and it's 8 gig or 4 gig, 6 gig, and the disk size usually is it SSD or non-HDD, and how much the size, 1 tera, 2 tera, 3 tera, and the operating system, is it Linux, Windows, Macintosh, and others. These are the properties or the behaviors that differentiate between one laptop from another laptop. But every laptop, whether it's Macintosh or Mac or Linux or Windows or has a RAM with 8 gig or 6 gig or whatever, so every one laptop has a startup, shut down at least, get operating system, set operating system, and so on. Thanks for